So we got compound events. Two or more simple events, often happening after each other. One thing happens first, then another thing happens. So we got 3 boxes here containing different marbles. And we're going to start by making a tree diagram, because first a box is chosen and then a marble is selected. So when we draw our tree diagram, we draw the first branches of our tree to the first event. So what are we doing first? We're choosing a box. And we have 3 choices: box 1, box 2, and box 3. Each of those choices has an equal probability because it says that a box is chosen at random. So what we can do on the branch is actually show the probability. The probability of getting box 1 is 1 out of 3, box 2 is 1 out of 3, and box 3 is 1 out of 3. Then the next event is you choose a marble. And in each of the boxes you have 3 choices, so off of each of the boxes will be 3 branches. Whoa. Sometimes you might run out of room. There we go. And the colors are white, black, and red. So I go white, black, red, white, black, red, white, black, red. And then on the branches, maybe I'll change color here in case it gets a little bit small. In box 1, you can see that there's 16 marbles in total, so the white one will be 8 out of 16. You could reduce that fraction, but I'm going to keep it 8 out of 16 because then it makes sense for what we have there. And the black ones are 2 out of 16, and finally the red ones are 6 out of 16. The next box has 12 marbles. The white one is 4 out of 12. The black one is 5 out of 12. And the red one is 3 out of 12. And finally, the last one has, how many? 9, 12 again. 2 out of 12 for white, 7 out of 12 for black, and 3 out of 12 for the red. So this is our tree diagram. And we want to find the probability that a marble selected is red. Well, can you see that there's 3 cases? You could get a red one by going through box 1 and then red. You could get it by going through box 2 and then red. And you could get it by going through box 3 and then red. So we could write this out in probability notation. The probability of getting a red one would be equal to the probability of box 1 and red plus the probability of box 2 and red plus the probability of box 3 and red. Now you wouldn't have to show that step, but that's just showing the idea of the different cases that come up. And whenever there's separate cases that happen, you always add them up in the end. So first of all, we have the chances of getting box 1 in red. That would be 1/3 times by 6 out of 16. So the chances of any branch at the end, you multiply the probabilities of each branch to figure out that chance. The second one would be 1/3 multiplied by 3/12. And the third one would be 1/3 multiplied by 3/12 again. So we type this whole thing into our calculator. And as a decimal, I get 0.292. I took that decimal on my calculator, and does everybody know how to change a decimal back to a fraction on their calculator? Yes? No? Okay, so what once we got that answer, I changed it back to a fraction. So if you go to the decimal, this is an approximation and you have to do the 3 sig figs. If you go to your fraction answer again, you could just say it's equal to 7 out of 24, and then you could use regular equal sign because this is an exact answer and this one is an approximation. So I'm going to get you to try the second example there. So again, we can draw a tree diagram. What happens first? We got to pick a marble out of one of the boxes. We're not picking a box at random here, but we're picking a marble out of one of the boxes. So if the first thing we do is pick a marble out of box A, well, there's going to be two choices. It's going to be red or green. And getting a red one out of box A would be 4 out of 7, and getting a green one would be 3 out of 7. Then once you've chosen one out of box A, next you're going to choose something out of box B. So if I chose the red one, I'd still have 2 choices out of box B, and I'd still have 2 choices out of box B if I'd chosen a green one. Because out of box B we have 2 red and 2 green, so it'll be 2 out of 4 for red and green, 2 out of 4, and red and green. The same thing happens down here because it's the same box. Now we want to find the probability that you choose 2 balls of a different color. Well, if you chose red first, then you would choose green. That would be our first case. But if you had chosen a green one out of box A, then you'd have to choose a red one out of box B. So our probability of different colors would equal 4 out of 7 times 2 out of 4 plus 3 out of 7 times 2 out of 4. Again, you could go to your calculator for this, just showing you some non-calculator type of math that could help you figure this out quicker. Do you see that there's a 2 out of 4 or 1/2 in both of these? Which means you could factor it out. If I factor out that 1/2, what am I left with? Just 4/7 plus 3/7, and those already have a common denominator. And that is just 7 over 7, which is 1, and 1 times 1/2 is 1/2 or 50% chance.